Antidifferentiation. Antiderivative of x to the r power, for r is an integer, so antiderivative x to the r power dx equal x to r plus 1 power over r plus 1 plus c. For example, antiderivative of x so equal x to 1 plus 1 power over 1 plus 1 plus c equal x square over 2 plus c. But for numbers, antiderivative of numbers, for example, is 3 dx, so equal 3x. In the antiderivative of 120 dx equal 120x plus c. For antiderivative of 2x plus 3, we use this formula, so equal antiderivative of 2x plus antiderivative of 3, so equal 2x 1 plus 1 over 1 plus 1 plus 3x plus c, so equal x square plus 3x plus c. If negative, we just change if negative, minus, so you just put minus here, put minus here. If minus, this one also we change to minus. Minus, this one still plus, this one minus, if minus. We see another example. Find antiderivative of this question below. Number 1, antiderivative of 12 equal 12x plus c. Antiderivative of 2x plus 3 equal 2x 1 plus 1 over 1 plus 1 plus 3x plus c equal x square plus 3x plus c. For number 3, antiderivative of 6x to half power dx equal 6 over 1 half plus 1 x 1 half plus 1 plus c equal 6 over 1 half plus 1 is not enough. I will erase this part. So 6 over 1 half plus 1 is 3 over 2 equal x 1 half plus 1 is 1 and 1 half. C 6 over 3 over 2. 6 divided by 3 over 2 is 4 x times x 1/2 plus c equal 4x square root of x plus c. For number 4, antiderivative of 2x minus 3 power dx equal 2 over negative 3 plus 1 x negative 3 plus 1 plus c. So negative 3 plus 1 is negative 2. 2 over negative 2 is negative 1 x negative 3 plus 1 negative 2 plus c. Or I can write like this. Equal negative 1 x 1 over x square plus c. So for number 4. For the antiderivative of, in parenthesis, ax plus b to r power, the antiderivative equal 1 over a in parenthesis r plus 1 multiplied by, in parenthesis, ax plus b to r plus 1 power plus c, and r is not equal negative 1. You see example here. Integral antiderivative of 2x plus 3 4, for example, dx. So equal 1, the a, this one a, so it's 2, multiplied by this one the r, 4 plus 1, 2x plus 3 to 4 power plus 1 plus c. So the answer is 1 over 10, 2 times 5, 2 multiplied by 5 is 10, 2x plus 3 to 5 power plus c. For the antiderivative of, in parenthesis, ax plus b to r power, the antiderivative equal 1 over a in parenthesis r plus 1 multiplied by, in parenthesis, ax plus b to r plus 1 power plus c, and r is not equal negative 1. You see example here. Integral antiderivative of 2x plus 3 4, for example, dx. So equal 1, the a, this one a, so it's 2, multiplied by this one the r, 4 plus 1, 2x plus 3 to 4 power plus 1 plus c. So the answer is 1 over 10, 2 times 5, 2 multiplied by 5 is 10, 2x plus 3 to 5 power plus c. Okay. Find antiderivative of, in parenthesis, 2x minus 1 to square dx. Remember the formula in the page 4. Antiderivative of Remember the formula on page 4. Okay, for number 1 equal 1 over a, this one the a, this one r, to x minus 1 square 2 plus 1 plus c. 2 times 3 is 6. So the answer. For number 2, this one the a. Careful, this one the a. Negative 4. This one r. Negative 3 plus 1. 6 minus 4x. Negative 3 plus 1 c. One over 8, 6 minus 4x, negative 2 plus c. Or we can write 1 over 8, 6 minus 4x square plus c. For antiderivative 1 over ax plus b dx equal, if ax plus b bigger or more than 0, so this formula we use. If a plus b smaller than 0, so this formula we use. For example, antiderivative of 1 over 2x plus 3 equal dx, so equal if and x bigger than 0. So 1 over a, this one the a is 2, this one the a 2 log e 2x plus 3 plus c. We'll see another exercise. Find the antiderivative of this question below. We see the x is bigger than 2/3. Bigger than 2/3 can be 1, 2, 3, 4, and so on. We type if x is 1, 3 x times 1 minus 2 equal 1. 1 is bigger than 0. So we use the formula on page 6. 1 over a log e ax plus b plus c. It's on 5, so you write 5 here. The a is 3, so over 3 log e 3x minus 2 plus c. So for number 1. Now we try for number 2. Smaller than 1/4 can be 0, can be negative 1, can be negative 2, smaller than 1/4. We took, for example, is 0. 1 minus 4 times 0 equal 1. 1 also bigger than 0, so we use this formula. You can see, so it's 3 here, so you write 3 over the a. Be careful, the x is have a x variable, so the a is negative 4 log e 1 minus 4x plus c. This is the answer. Antiderivative of e epsilon to kx power is 1 over k e kx power plus c, and k is not equal 0. For example, antiderivative of e to 2x power equal, so this is the x, so 1 over k is 2, e to x power plus c. We will see the another exercise. Find the general antiderivative of each of the following. Remember the formula on page 2 and page 8 before. So integral of antiderivative of e kx dx equal 1 over k e kx plus c. So for this one is the k is 2, 1 over 2 epsilon 2x plus we have solution 3. Remember formula on page 2, 3 over 1 plus 1, x is 1 plus 1 plus c. So the answer is 1/2 epsilon 2x plus 3 over 2 x squared plus c. And then another for number 2. For this one, equal antiderivative of, make sure this one going up, so to make it easier. So 2x, if divided, it means minus, plus this one going up, it become a minus. So antiderivative of ex minus plus minus x dx. This is formula 1 over k 1 over 1 ax plus 1 over negative 1 e minus x plus c. So equal ex minus plus c. This is the answer. Find y in terms of x for each the following. Remember formula on page 8. Antiderivative of a kx e kx equal 1 over k e kx plus c. So for this one, antiderivative of 2x y equal, antiderivative of 2x is 2x minus x equal 1 over k, the k is 2, e to x minus 1/2 x squared plus c. We keep it first, this one, we keep it first. This one we keep it first, so I put y equal 1/2 e to x minus 1/2 x squared plus c. Now I try to find the c. When y equal 5, x equals 0. So y 5, x 0, 2 times 0, substitute x becomes 0, plus c. Remember, everything exponent or to 0 power equal 1. One, 0, plus c, 5, 1/2 plus c, 5 minus 1/2 equals c. So c equal what 1/2. Now I substitute to here. So y equal 1/2 e to 2x power (1/2 e to x power negative 1/2 x squared plus 4. Here the answer. If x is continuous function on an interval a until b, then antiderivative of fx with interval a until b equal gb minus ga, where g is an antiderivative of f. For example, integral of the antiderivative of 2, this one is 1, this one is 2x dx. So equal, this one is x squared, antiderivative of 2x is x squared, interval is 1 over 2, so 2 squared minus 1 square, 4 minus 1, so equal 3. You'll see another exercise. The following is the following. We will try to do number 1 first. So this one is 2 over t2 plus 1 x plus 1 plus 5 over 3 plus 1 x 3 plus 1 with interval 1 until 4. So equal 2 over 2 3 over 2 plus 1 is 2 1/2, 5 over 4 with interval 4 and 1, so this one will come 4 over 5 x squared times x 1/2. If time the exponent is plus 1, so this one equal 4 over 5 x squared square root of x, so this one x 4 interval 4 until 1. Now we try to substitute. Now 1 and 4. So equal 4/5. We substitute x become 4. Root 4 plus 5/4 whole exponent by 4 minus 5 1 square root 1 plus 4/5 1 exponent by 4 1 exponent by 4 equal 128/5 plus 320 minus 4/5 plus 5/4 equal 128/5 plus 320 minus 41/20. 320 plus this one, this one, 20, make the denominator the same, 20, 220 plus 171/20. Equal 220 plus 23 11/20. 343 11/20. This is the answer. Now we try to answer number 2. Remember the formula on page 4. And the derivative of ax plus b to r power equal 1/ar plus 1 plus 1 ax plus b r plus 1. See for this one, so that equal 1 the a is 2 plus negative 3 plus 1, 3 plus 2x, negative 3 plus 1. The interval is 2 until 0 until 2. So 1/-4, 3 plus 2x, negative 2. 2 until 4, 0 until so equal negative 1/4, negative 1/4. This one is 3 plus 2x square to 0. So equal negative 1/4. We substitute time 1 over multiply by 1 over 3 plus substitute the x with this one square minus negative 1/4 multiplied by 1 3 plus 2 times 0 equal negative 1/4 equal multiplied by 7 square minus negative 1/4 1 over 3 square equal negative 1 over 196 plus 1 over 36. Make denominator same. Equal 40 over 1764 equals 10 over 441. This one the answer. Now we try to answer number 3 now. Remember the formula for antiderivative of e exponent by kx equal 1 over k e exponent to kx power plus c on page 8. We try to answer number 3. So 1 over k, the k is negative 2, e to negative 2x power plus 1 is equal to x. The interval is 1 until 0. So equal 1 over negative 2 e negative 2 times 1 plus 1 minus 1/2 e negative 2 times 0 plus 0. So equal negative 1/2 e negative 2 plus 1 minus everything exponent by 0 is 1, so negative 1 times 1, so equal 1 over negative 2 e negative 2 plus 1 plus negative, meet negative become plus, so the answer equal negative 1/2 e negative 2 plus 1 plus 1/2 equal 3/2. This is the answer. Yeah, find the area under a curve. You can see, you can read the rule here. If this one here, this one is positive. If this one under the curve, under the x, so we put minus here, minus. We will see another example after this. Sketch the graph and find the exact area of regions bounded by the x-axis and the graph of each of the following. Y equal 3x squared plus 2 between x equal 0 and x equal 1. Here the graph between x equal 0 and x equal 1 and x-axis. So this area, the x-axis is here, x-axis is here, and then 1 is here, this one 1, this one 0. So the area, it should be here, this area, until here. To find the area, derivative of 3x squared plus 2 equal 3, 2 plus 1, 3/2 plus 1, x squared plus 1 plus 2x. The bounded is 1 and 0 to 1. So equal x cubic plus 2x between 0 until 1. 1 cubic plus 2 times 1. We substitute the value of x. 0 cubic plus 2 times 0. So equal 1 plus 2 minus 0. So the area equal 3 square unit. For each of the following, sketch a graph to illustrate the region for which definite integrals gives the area. Integral or antiderivative of 4 minus 2x squared dx between negative 1 until 1. Here the graph, negative 1 is here, is negative 1 here, 1 is here, 1 is here. So the area, negative 1 until 1 is the area is here, this area. Okay, find the area is in antiderivative of this one is 4 become 4x negative 2/2 plus 1, 2 plus 1 is 3, 2 plus 1 is 3, negative 1 until 1, between negative 1 until 1. Substitute 1 cubic minus 2/3 negative 1 cubic. So equal 4 minus 2/3. I open the parenthesis. Plus 4 minus 2/3. 8 minus 4/3 equal 6 2/3. So the area is 6 2/3 square unit. Integration of circular function. Integration of sine kx plus a dx equal negative 1 over k cos kx plus a plus c. If sine, it become negative cos. If cos, still positive sine. You see the exercise. Find antiderivative of each the following. Cos 3x. Remember the formula on page 17. So equal cos still positive 1 over k is 3, becomes sine 3x plus c. For number 2, 1 over sine become negative cos, negative 2, the k is 2, so negative 2, become cos 2x minus pi over 3 plus c. For number 3, equal 1 over the k is 3 sine 3 theta, sine become minus 1/3 cos 3 theta between 0 until pi over 3. Now we substitute the value. 1/3 sine 3 times 3 pi, 3 times is 1, equal pi minus 1/3 sine 3 times 3 pi, become pi, minus 1/3 sin 3 times 0 is 0, minus 3 cos 3 times 0 is 0. So equal sin pi is 0. So this one is 0. So this one is cos. This one is cos 1/3 cos pi. Sin pi is 0. Cos pi is negative 1. Zero, negative 1, minus sin 0 also 0, minus cos 0 is 1. So equal 1/3 negative, negative become plus 1/3. So the answer is 2/3 square unit for number 3. Find the exact area of the region bounded by the graph of y equal 12 minus x square and y equal x plus 4. The red line here, the red line is the curve y equals 12 minus x square. And the purple line, this purple line is y equal x plus 4. And the area, the boundary area is this one, the boundary area between curve. So we can see that the curve is above the line. So the curve is first. So it's y1 is above. Y1 is the 12 minus x squared. First and above, and the below is the line. Is x plus 4. to find the bounded area, find the border y equal y. So x plus 4 equal 12 minus x squared. So x squared minus x move to here, become plus, so 2x. 12 minus go there, become negative. 4 minus 12 is minus 8 equals 0. Plus 4 and negative 2. So x minus 2 equals 0, so x equals 2. X plus 4 equals 0, so x equals negative 4. See, the boundary area is negative 4 and 2. Now we try to find the antiderivative, the region of the bounded area. y1 minus y2 dx, so equal 12 minus x squared minus x plus 4 dx equal, since boundary area is negative 4 until 2. So antiderivative of 2 negative 4 negative x squared minus 2x plus 8 dx, so equal negative 1/3 x cubic minus x squared plus x, so negative 4 is 2. We substitute the value now. Substitute the value, 2 and negative 4. So 1/3 negative 1/3 2 cubic minus 2 square plus 8 times 2 minus negative 1/3 negative 4 cubic minus negative 4 square plus 8 negative 4 times negative 4, so equal negative 8/3 minus 4 plus 16 minus, in parenthesis, 64/3 minus 16 minus 32. So equal negative 8/3 plus 12 minus 64 3 negative, and negative become plus. 16 plus 32 is 48. So the answer is 60. 12 plus 48 is 60 minus 72/3. So equal minus 24 equal 36 square unit. Find the shaded area. The red line is equal cos x, and the blue line, the graph of the blue line, is equal sine to x. We'll divide become 2. It's on the first area. So the second area. first area and second area. In the first area, you can see cos is above and the line sign is below. So the first area is integral 0 until pi over 6. Cos is above, so cos the first minus sin 2x. The second area, sin is above, so sin the first pi over 6 until pi over 2 sin 2x minus cos x. We try to finish this first part. Derivative of cos is sin x, you get minus derivative, antiderivative of sin 2x is negative 1 over 2 cos 2x. So equal since 0 until pi over 6. So equal sin x plus minus with minus become plus equal sin x plus 1/2 cos 2x pi over 6 0. So you substitute pi over 6 and 0 equal sin pi over 6 plus 1/2 cos 2 times pi over 6. 2 times pi over 6 is pi over 2, pi over 3 minus sin 0 plus half cos 0. So equal one half plus 1/2 times 1/2. I think not enough here. I erase this part. Equal sin pi over 6 is 1/2 plus 1/2 cos pi over 3 is 1/2 minus sin 0 is 0 plus 1/2 times 1 cos 0 is 1. So equal one half plus 1/4 minus 1/2 to cross, so equal 1/4. So for the first part, this first part equal 1/4. I keep here, this one is 1/4 and plus the second part. We got already the first part, now we try to find the second part. Derivative of antiderivative of sin 2x equal negative 1/2 cos 2x minus antiderivative of cos x is sin x. The interval is pi over 6 until pi over 2. So we find the answer here. Negative 1/2 cos 2 pi, substitute to here, sorry, not this one, substitute this pi, substitute this one to here, so cos 2x, the x change, substitute pi over 2, so cos 2 times pi over 2 is pi, minus sin pi over 2, minus negative cos 2 times pi over 6 is pi over 3, minus sin pi over 6. So equal, I use this part, this first part I use, so equal negative 1/2 cos pi is negative 1, minus sin pi over 2, so minus 1, sin pi over 2 is 1, minus negative 1/2 cos pi over 3 is 1/2, minus sin pi over 6 is 1/2. So equal one half minus 1 minus 1/4 minus 1/2. So equal negative 1/2 become plus 1/4 plus 1/2. So it's a cross. So I got 1/4. So the second part also 1/4. So the first area is 1/4 and the second area also 1/4. So the answer is 1/2 square unit. An object start from point O and move in a straight line. After t seconds, t is bigger than or equal 0. Its velocity v meters per second is given by v equal to t minus 3. Find A, its position x in terms of t. A, so as antiderivative of the x equal antiderivative of velocity to t minus 3 dt so x equal two over 2 square minus 3 t, so x equal t square minus 3t. B, find its position after 3 seconds. We got the x equal t square minus 3t. So the position after 3 seconds equal x equal, substitute the t equals 3 seconds, square minus 3 times 3, 9 minus 9. So the position is, position x is equal 0 meter. Find average velocity in the first 3 seconds. So V equal x3 minus x0 over 3. x3 equal 0. We can find the part B. x0 also, because the x is t square minus 3t, so x0 also 0 over 3. So the velocity is 0 meter per second. D. Find the distance traveled in the first 3 seconds. When V equals 0, so 2t minus 3 equals 0, 2t equal 3, t equal 3 over 2. And then x equal t square minus 3t equal 3 over 2 square minus 3 times 3 over 2 equal 9 over 4 minus 9 over 2. So equal negative 9 over 2. So for the first 3 over 2 seconds, the x equal 9 over 2 meter. And then back to x equals 0 in the next second. When the back to x equals 0 in the next second, the x also, the distance is 0. So the distance for the first 3 seconds is 9 over 2 meter. E. Find its average speed in the first 3 seconds. So the average speed equal 9 over 2 over 3 seconds. 3, so equal 9 over 6 equal 3 over 2 meter per second.